Good evening. My name is Gabriel Lane. I'm a sophomore computer science student from Waldorf, Maryland. And if you're like me, you're a huge NFL fan, one of the questions you probably asked yourself last year was, how does Patrick Mahomes throw that ball so well? Well, the key to that question lies in a topic called projectile motion, which is the topic I'll be discussing today that I've learned in a previous college physics course. So, to start with, we'll discuss position velocity acceleration, or PVA, and we'll see how that eventually applies to projectile motion itself. And then we'll get the help of some actual physicians to tie the full story together. But to start with, what is PVA, position velocity acceleration? Well, according to Mechanics Map or psu.edu, the explanation is pretty cut and dry. Position is the location of an object in space. So wherever something is, if you think about Patrick Mahomes again, where he is in that yard line, his space in the field, that's his position. Then velocity is the rate of change of position. So this is a little deeper. This is how fast is position changing from one point to another. Let's go to Mahomes again. When he snaps that ball, he does a 3-step drop. How fast is his position go from here to here? That's velocity. And then finally, acceleration is the rate of change of velocity. And I know this is getting a little redundant, but hear me out. Once again, we have Mahomes dropping back. But what if a linebacker rushes him or something? Now, he's like right here, he got me right here quick. Acceleration measures how fast does he speed up, or how fast does he slow down. And so that's basically position velocity acceleration, but how does this all apply to projectile motion? Well, luckily, according to compadre.org, we get the help of Galileo and Newton to tie this full story together. And according to Galileo, projectile motion is just the application of PVA in an XY plane. And what do I mean by that? That is horizontal and vertical motion just combined into one. So think about Mahomes again, throwing that ball. He's got the ball in his hand, and wherever he is, that's the position he gives that ball before he throws it. When he throws it, what velocity, what speed is he adding to that ball as it flies into the air? That's velocity. Then, finally, how is that ball traveling and speeding up towards the ground or slowing up as it reaches its peak vertically? That is acceleration. But where did acceleration just come from as it flew in the air? Well, Newton explains that that's the force of gravity. Gravity is the pull that keeps an object from just accelerating speeding up all the way into the atmosphere and pulls it down to reality. It slows down, and it's present throughout the whole throw. It slows down as it reaches its peak, and then accelerates it towards the ground right into Travis Kelce's hands. I know that's right. But that's essentially projectile motion. When an object travels in space, it gets an initial velocity, and the universal force of gravity carries it throughout the flight, reaching its peak, then coming safely down to the ground. And so that's essentially the topic of projectile motion. But look at all the questions we've had to ask. Before we even get to throwing and where we want to throw, where am I? How hard am I throwing this? How high do I have to throw this, making sure it doesn't reach the ground too quickly? All questions that we all must come together with in the mechanical universe. So, thank you.